Hello everyone, this is Ian. In this video, I'm going over the changes I've made to Random Flow version 1.5.0, and let's start off with Random Loop Extrude. So right now, the Subdivide Edges solver is going to be the default one. The other solver has been removed to avoid confusion and also to avoid crashes when switching between the two, especially when using the um, or higher subdivision levels. And we also have two new toggles, which is the individual solver path and the inner outer materials. So right now, all the loop objects are using recursive and none path. Solver recursive and path is none. All of them is using that. If we toggle this on, we can assign the solver and path for each loop object. So for example, loop one object here, the solvers and the paths are being represented by numbers. Number one is sampling in solver, two is recursive, and three is radial. And path one is none, two is shortest, and three is longest. So for example, number one, we're using sampling and longest edge. Number two is sampling or recursive. Let's use recursive and using shortest uh, edge. So as you can see, we can create more effects using this. And we have a new solver, which is radial. In radial, the paths do not work, so just remember that. It only works for sampling and recursive. And if we toggle on original only, this means that all of objects will now be sourced from the face selection. Let's just 80 for this too, and 10% of the faces. Increase the subdivision. Now we can create more effects. Switch back to regional only. Now you have more option to create more details, and you don't have to use two separate operations to create varying shapes or varying solvers and paths. You can create it in one go using the individual solvers and paths. So for the inner outer materials, if you toggle this on, it will create a material, two materials for the random objects. Uh, our flow temp mat one is going to be the material for the interfaces, and this dark patch here is going to be the our flow temp mat 2. The add-on will always be using these two materials here. If you rename this, it's going to be its own unique material, and the add-on will just create another one with the same name. So it's always going to be uh, um, looking for these two unique materials. So my advice is when you're modeling, um, don't change it up. Change this later when you're done modeling. You can edit this, use nodes, and change the name after you're done modeling, and not while you're modeling to avoid confusion with the materials. So that's for a random loop extrude. The default solver will now always be the subdivide edges from the documentation. You can read that in the past there are two solvers, one with the subdivide edges on and one with it off. So now subdivide edges will always be on, and we have the two new toggles, which is the individual solver path and the inner and outer materials. Now let's go on to random panels. I'm going to explain a bit more with the radial here. So as for the radial, so the sampling and the recursive acts like this. It walks the faces to create the islands. And when sampling and recursive hits uh, a point where it has nowhere else to go, sampling randomizes once, and on some device tries to look for a new open path once, so like this, and then that. But if it doesn't um, and if it doesn't find a new path in that single attempt, then the operation stops or the walking stops. In recursive, you get to um, every edge here is being tested as a new path. So for example, if this fails, it will just walk, and for example, if this passes, then it will create a new path here. So that's the sampling and recursive. With radial, it randomizes a face, so a face origin, then does this to create the islands. So that's why in this pattern here you get mostly squares. But if we change it up, here, so it also depends on the underlying topology. So if you want these square patterns, you gotta have even topology underneath. And to get mostly this, so this is kind of like this is part of a way you can control the result of the solvers is to control the underlying topology or the face selection. So for example, we have this. And versus an even one, and we get mostly squares. So to get this effect, the square effect, be sure to have an even topology, and to get something like this, you can design the topology underneath. So to get mostly squares, we are going to have to edit the underlying topology. So you might be wondering why you can't get the same squares that I'm uh, getting in my video, and this is how you do it. Versus if we use a different topology, an uneven topology. So you're going to have that. So it can't really do too much with that topology, so you have to actually give it some help and create new edge flow. So you can see here, the path doesn't work with radial. It's the same with random loop extrude. And we also have the inner outer materials toggle in the random panels. And let's get rid of this. Let's use recursive. And it will mark those inner and outer faces, inner and outer, with the same materials I have demonstrated in the random loop extrude. So inner and outer materials, you have to decide very early on to use this feature because it helps with the selection later. So for example, if I just select a face here and press Shift G, this is an inherent command in Blender. Shift G to select similar and use material. You can see that it selected only the inner faces. Then I could use the same command to create another random panel effect on top of the previous or the earlier um, random panel result. So this is the layering system. Then again, selecting the new one, Shift G. So it just and you can continue and continue uh, to do this to create smaller and smaller details. And you can also use this in combination with the new functionality, which is the Shift G material, panel screws, margin. So it makes the selection much easier. Use angle threshold. Okay. So before we move on, the inner outer materials cannot be inherited. So for example, material preview. If I assign material here and use random panel, and this with this toggled on, it will no longer inherit the material underneath. Versus with this off, it inherited the shader from the source material or the face selection. But if you use this, it will not inherit the select this new object. Oh, I'm using the there we go. So if we turn off the inner outer materials on an object that's using the our flow temp mats, it's not gonna inherit those unless you in settings you use the copy temp mats. But in this case, since this will only copy the material based on the active material and the index, so 0 is our flow temp mat 1 and number 1 index is our flow temp mat 2. If we use negative index -1, it's going to copy the active material instead. And in this case, this is the airflow temp mat 1. And let's just turn this off. So if this is off, then the random objects will not inherit the airflow temp materials used for the inner and outer faces for random loop extrude and random panels. Okay, let's move on to random scatter. What's the new one here? There's nothing new here. Oh, there's something new here. The margins. So the previous margin is now named as cluster. You can see it's going to cluster on the triangle face or the point, which is where we or the center point of the triangle in the face. And margin is going to be the margin of the face selection. It's kind of like inset. So this is the margin. And cluster. Now we go to random tubes. So random tubes now has a new toggle, which is limit body. And you can see here that this pipe is being sourced from a point. Uh, so this uh, pipe here or tube, one of its cap or end and start point is being sourced from the body points of this of another pipe. So this creates more pipes, but you have to really play with this with the offset seed to make them overlap correctly versus using the limit body to go. Each pipe will avoid creating its head and endpoints from the body points of another pipe. So you can see here there's a space between them. There are spaces between them and versus limit body off. You can see that it's some of the end and start and end points of the tube is originating from the body of another tube. And random cables. So random cables right now is alpha version. Right now it only has one effect, which is the catenary. I've chosen to go with catenary first because it's the most interesting effect for me. So it can work on multiple objects selected, and it works on faces selected. If you have ISOs Pro, you can you can extract proxy or temporary face selections using the Git polymesh, and then use this for the um, cable origins, and then just delete the faces afterwards. So let's select this face. So uh, the catenary cables will always points towards down the down Z direction. We have the slack, the minimum, and the maximum. Don't worry about the minimum overlapping the maximum. If the minimum becomes larger than the maximum, then the role will reverse. The minimum will now be maximum. So don't be afraid about uh, trying to make the maximum higher than the minimum. Just look at the result in the viewport and what's it doing with the wire or the cables. So we have the origin seed. Origin seed means the location of each start and end points. Cable amount. This is not exact. This will only give you the approximate number or the highest possible number of cable, because some conditions will not allow for the tubes or the cables to be created. So this is the maximum possible cable amount of cables to be created. So for right now, this is 40. So select seed. We have the bevel resolution. I think this is the radius of the. There we go. And resolution. Right now I'm using 0. You can increase it. You can use 0, but this is going to be if we apply this. Apply mesh. You can see that it only looks rounded because of the smooth shading. So if you want to, you can use the resolution 0 if you want to make the if you want to make the scene lighter, because at certain distance you can't really tell if the cable is just using um, 4 face loops up. Yeah, four face loops. So one, two, three random cables. We have the resolution, and the resolution U is the resolution of the entire curve. So as you can see, it's changing while I'm. So let's use 0, and it also, these two are connected with each other. We have resolution here. So I usually use it at 0 and just increase the steps. So again, just play with the settings, and to make the scene lighter, you can use just a right amount of resolution and steps to create the curvature, the curved look. Or you can use this and create a new subdivision modifier later. We have the extrude. So I usually don't use this in my video, but it's here if you want to use it. You can twist it, tilt it, to make it look like that. And this also, I don't use it that much, but it's good that it's here. Sometimes maybe the cables may have some twisting artifact. You can use this to fix it by increasing the twist smooth. We have the radius. So the radius, we can randomize it. Let's decrease the extrude to create this effect here. And offset, this is the offset of the faces that you've selected, and they are being offset using the normals. You can see. So these are the faces that we've selected, and they are being offset. So those are the face origins. So you can bury the, you can make the cables dig in deeper, and this is the margin. Basically makes the selection, face selection smaller. So be careful of using one. For all those that are using margin, I'm using a really simple technique, and that is the inset. So for example, this is the original faces selection. I'm just insetting them to create the margin effect. For some operator, the margin can go beyond negative one or beyond the one value, so it can go like this and go like, yeah, go like this. So it can create distortions, or sometimes, as you can see here in our example earlier, increasing the margin results something like that. So if you see that, or if you see the cables kind of like distorted, check the margins. This is also true for each operator that is using the margin property. Check the margin if it's not margins, if the result is not showing you um, a correct result. So random tubes also, we have the margin. It's like that. It doesn't reset on each operation, so each faces have different sizes. So for example, if I use a smaller face after this one, okay, so it went past the, it's, I think this is, to be safe, just go to 0. So you can see it's now really big. So just watch out for the margin properties in each of the operators that's being used by the add-on. So what else we got with the cables? Okay, random cables, limit origin to islands, and join curves into one object. Okay. So if this toggle is on, and if I press this, you can see that it doesn't have a result. What this means is that the cable should only be sourced from each separate islands, but since we're using a single island, so it's not doing anything. We have to turn this off. If you're use if we are using a single island, we have to turn this off. Okay. So if we, for example, if I'm using multiple islands, and I have this off. You can see that some cables are being sourced from there, are being sourced from their own islands. So to prevent that, I'm going to switch this on. As you can see, the head, the start and end points of each cable have different islands. Versus turning this off, some cables will have start and end points using the same island. So let's select this to prevent that. And the other toggle, join curves. This is the curve here, a single object. Turning this off will, of course, make every single curve object here as its own unique object in the scene. Only if you want that, but you can see that it's populating the outliner. So join them as single object. Okay, so we go to flanges and couplings. This works for both the result of random tubes and random cables. Okay, let's go to random tubes first. Flanges. So operator presets, we also have this. So cylinder, default. We have the radius and the depth and the segments. So cylinder is only for light renders. So for some distance, you only need the shape of a flange or a coupling, or you only need a low poly object to indicate or to suggest the shape of a flange or a coupling, so you didn't need that much detail. So if you want a lighter object, proxy object for that, you can just use the cylinder. We have the segments, the rotation. At seed number 1, the rotation of each object is not being randomized. It will only be randomized at seed number 2 and above. So you can see here, if I rotate this, you have uniform rotation. But if I start raising this up, so this makes every flange or coupling have a different rotation. So it makes everything seem natural. So limit, we have caps and body. With none, both caps and body will be flanged or coupled. Even count, turn this off. So right now we have 1. If we use 2 and 3, every pipe has 3 flanges versus even count. Now it depends on their length. So quantity and then step. These are relative. If we decrease step, the amount property will have more effect. Think of this as this step is kind of like an interval and also increases the spaces between the pipes, the flanges, I mean. So let's use quantity of 2 and increase the step. So now it depends on their length. You can see this tube here has 2 flanges, and this tube here has 3 flanges. Also makes this looks more natural. And if you want even count, you can use you can also use even count if you want. And the only uh, side effect with using the non-even count is this. You can have something like this. So we're going to offset that. So caps is going to offset using the normal of the faces it's originated. It's not going to follow the tube body. And the body the body will indicates the flanges that's in the body of the tube or the cable, and it will follow the shape of the curve. So to fix this, we're going to use this. There we go. And maybe play with this as well to make it more even. So I also have custom. There's going to be a folder in the add-on folder. Just the folder for this is flanges. I have a couple of this made. So let's go to cylinder first and use a lighter setup. Cables. Oh, this is for cables. This is not for pipes. Cable couplings only two. Flange. So this is the first one. Flange 2. Heavy. Going to have more resolution. So you're going to have the lag that you will experience with this is the resolution of the curve that you're using the operator with, and also the resolution of the custom object you're using. So caps, this is only for caps. Where's the radius? And the other one. So if you want a different uh, flange for the caps of the tube, and the caps means the start and end points of the tube or the cable. If you want a different um, flange or coupling for the body and the caps, then you have to uh, use two operations for that. First for the caps, and then for the body, or in reverse. So radius, and then select the body again, the tube again. Oops. This time body, and use one for the body. There we go. If you want to change the caps, just delete it and use another one. Caps, and increase the radius. They will come out and then flat shaded, so just select them and use auto smooth. So to create uh your own flange or coupling object, make sure that the cursor is in the world origin. I'm going to import um the example, an example. So this is one of the flanges. You can see how big it is. So in order to make it easier for you, this is how I think the default cylinder. There we go. Okay. That's how big it is. That's how big it should be. And it should be at the world origin. Then you can play around with the size. This spot here where the green axis is, or in the middle, is going to be this spot here in the caps. And for example, if I import that, there we go. And you can see I've offset it a bit, and you can see it here. It's also offset a bit from the face. After you've done modeling, be sure to apply the rotation scale. So this is the up uh, the up direction, which is going to be followed by the operator when trying to orient the objects. And after you created your own design, so for example, if I have auto mirror here, say, so after you created your own design, optimize the resolution, uh, press F4, export as STL. STL only, it will only work as STL, and export it to the folder, Flanges folder in the add-on directory, and don't touch anything in the settings, just use the toggle apply modifier and use selected object only. And be sure that it's in the world origin. Okay. Now let's go to the collections. Let's just make a few sample. Okay. So selecting these objects, let's use auto smooth. Control G to group them. And then after that, press F9. So because it's going to be uh, grouped by default to the collection. So change it something like 11, and then we can use that as a randomized object collection for the pipes or cables. Couplings collection. If you have thousands of objects in a very big scene, if you select this collection, prefer to crash. Save often. So let's use the 11 and let's use none. You can see that it's using all the shapes. We can randomize the shapes using the object seed. Quantity. So it makes for I. So you can see that I'm in the documentation. There's a section about the controls you can use in the redo panel. Right here, I'm using control middle mouse up and down, roll middle mouse up and down to modify this value. I'm not using slide because that will cause crashes on properties like the step. So for this, I'm using only control middle mouse button, rolling it up and down to increase or decrease the value. And I'm not using slide because that will increase the value so fast you might not it might result in a crash if you're using too much resolution. Also through here, so there's no problem with me using the slide. I mean, I'm hovering over this, then press slide left and right to modify the value. But in case the operation involves too much resolution and everything is too slow for you to use the sliding function or sliding technique to change the values, then don't use that anymore and only and you and manually just input the value, because that will give Blender time to think for the operation. Because if you're sliding, every fraction change in the number, Blender will try to process that, versus manually changing the value, it will only process that one single operation. So use this, use the sliding technique if everything is light and everything is um, fast. But if you're using it and everything's slow, manually just input the values to give Blender time to think. Okay, I think that's for flange. Now we're going to so it's the same thing for cables. And it will be much small. It will actually be much slower for cables. Just beware of using that, because especially if you're using too much of the resolution new and the steps, in here you can see that if I change the body offset, it's kind of slow, but still manageable. So I should increase these or remove geometries. This will make it faster because of the resolution. Or the thing that I designed. Radius. There we go. So again, if things starts to go slow, especially if you have too much cables and you're using it, then don't do the sliding uh, method to change the values of the properties. Just manually enter the values. Okay, now so let's go to panel screws. Where's that? Panel screws. Shift GT. Cursor to world origin. Create a new cube. Panel screws. So it will create screws on the corners of the face selection. See there? If you select a whole object, however, then it will have no island and you will have no screws unless you toggle this up. Selection boundary. So toggle it on, I mean. So every face becomes its own island. So for example here, this one single selection can be treated as an island, or we can use every single face in that selection as its own island. Okay. We have use angle threshold. Let's create a cube. So right now, this is angle threshold of 30 degrees. If we decrease it, then it will incorporate more of the angles or the vertices in the selection to create the, so you can see it's actually dependent on the position of the verts. And right now, the operator is slave or, or or slave to the amount or the topology that you have underneath in terms of the default number of screws that you can make. You can never go down past this. You can never go down past the number of vertices that you have in the selection. In the future, this may change as I incorporate new solvers. So we could have something like intervals. I'll show you later in what I mean in the when I use it in the cylinder. Okay, so if I don't use the angle threshold, then we can use subdivision to create new vertices in the edges. Where's the step? There we go. It's just a balance of the step. So by default step, this works for the default cube size, 0.01. As you go smaller, this is the soft minimum. You can go lower than this if you enter the value manually. So this is the default. If you decrease the step, again, this will make the this is kind of like the interval and the flange and the flange and the coupling operator. If we increase this, we increase the distance between the screws. So right now it's dependent on a um, very simple equation. No, a very simple method of acquiring this even spacing, and that is using the edges as well. So as you can see, it can fail on some situations. But it will work for most of the situations you use it with. Selection boundary, limited dissolve. So like I said, it's slave to the amount of selection that you have, amount of vertices in the boundary edges of the selection. Okay, let's make it smaller. Where is the radius? There we go. So you cannot go lower than the amount of vertices in the selection. So for you to even this out, we can use limited dissolve. So this dissolves all the vertices, all the edges. Let's extract this first, see to let you know what I mean. If we dissolve this, whoops. And this is what it actually did. It removed this inner edges and just left us with the corner verts. And that's what it does. So if we're not using limited dissolve, we're stuck with the amount of vertices in the selection as the minimum. But if you want to change that up, you can use limited dissolve to dissolve uh, the existing edges inside the selection and use the this is only for special use case scenario if the underlying topology does not give you the even spacing that you want, then you can use the limited dissolve. You can see here, parts here, it's kind of a bit offset than the rest versus this. Okay, selection boundary. And you can see that this no longer works because we have destroyed the faces inside. If we turn this off, turn this off. Be careful with this. If you switch, if you have high resolution in this default, uh, with this on, uh, yeah, with this on, if you have high resolution here and you switch this to per face, then you will probably experience slowdown. Okay, let's actually open up the pistol and turn off screencast. Here I use this as a Shift G and okay, material, no, not that. Link flat faces. Okay, panel screws, cylinder, and the margin. So right now it's creating edges, screws here and screws. There's a screw here which is not supposed to be there. So let's just use limited dissolve. Fix that. Again, the cylinder is here for light render purposes. If you only want a suggestion of the rivets or screws and modeling and creating high detailed objects like this one where it matter on the render distance that you're using, then you can just use the cylinder object to make it lighter. But if you have close-up renders, of course, you can use the high resolution custom objects. Okay, right here, angle threshold. Let's increase it to exclude this one here. I'm going to increase the threshold. But if doing anything of if any of the screws will not disappear by anything you do in the properties, then you can just confirm the operation, select the screws object, and just delete them manually. L, go to face mode, face selection mode 3, and then L. Hover over the faces L to select the whole face island, and that's just select delete them manually, or go to press A, select the object, go to edit mode, go to vertices mode, shift Z, and use the box or the lasso to select objects like that, and then delete X, F. So just like that. So you can see it's not perfect. And using too much limited dissolve has completely destroyed the face. And granted, this is a very exotic, weird type of face configuration, so that's to be expected right here. But on faces like this, on angular faces like this, it's no problem. Panel screws, cylinder. Again, watch out for the margin. The last setting that you've used. So this also have custom, have captive. Again, you can design your own using the same method that I've explained earlier. Captive 2, Phillips, and round head. I've beveled the sides so it well. Yeah, I should have beveled this one here too. That's for later versions. That's for just for them to look right in normal map baking. Yeah, I should have beveled this too. I'll rectify that in the next version. So this is the same. This is actually the same as the flange, and we have custom. We also have the collection, and the collection I should have never this uh, destroyed the earlier one. So Z is up. This is going to be the one that's facing us. Control G, F9, and rename it apart from the collection, because the collection is using every object in the scene, and we don't want that. So for example here, let's try the collection 11. Limited dissolve is too much. Margin. And we can adjust the use angle threshold. Too much margin and too much radius. For this kind of selection, there's always to be you just adjust the size of the screw, of course. Limited dissolve, 10. There we go. There. So it all depends on the topology that you have underneath. You'd have more chance of an even spacing if the underlying topology is also evenly spaced. So you can see there is still some weakness to the um, script, to the operators, but uh, it will become better in future versions. Also here, Shift G, material, cylinder. Good thing it didn't crash. 0.05 and use angle. Increase the radius. 0. Oh, it's slim. Oh, that's why it included the inner faces. I think I didn't use the oh, I got rid of the inner and outer materials. I forgot. Sorry about that. I began shading this. That's why I get rid of the uh, inner and outer materials. I didn't get rid of it, I just renamed it. There we go. And we have the center verts here. So right now also the center verts, can't get rid of the center verts. Which is this one, for example. X, Y, and Z. Oops. X, Y, and Z. And then use panel screws. Use angle threshold. So you can see we have the symmetry there. If you want to get rid of symmetry, you can do so manually. Afterwards, just delete the panel screws. But of course, the offsetting will not be the same. So it's up to you to. So right now, that's the problem. I will be resolving this in the future by introducing a new operator that will solve the symmetry offset. So right now, this is already really working as it should be. It's going to be weird on some topologies, but for most topology that is simple and so you can see there we have this one here. So we can only get this kind of spacing because we have this. We'll probably have 4 faces. Still the same thing. So you can just delete the afterwards. So like I said, for most situation it will work. Let's try this here. Really weird. Real weird setup. It actually followed the curve there. And this here is cylinder. As you can see, we're not going to go lower than this because this is the exact amount of, so 0.1 step 100. You can see it's not going lower than that. So in the future, you can set this. You can actually set the. You will be able to do this even on a cylinder with fixed resolution. You will be able to do this to create intervals like that. I actually made it work, but I didn't put it in because I'm hoping to catch up with the. I'm going to I decided to include it in version 1.6.0. So right now we have this, but it's already powerful and it will work on most situations. So adjust the margins and adjust the radius. We have the offset. We can use offset custom objects. So the custom object is located in the screws folder in the add-on directory. If you decide to make one, uh, put it there and use the STL format. Okay, so extras, mesh data, last one, finally. So English is not my first language, although I can write really well in English. We don't normally speak English where I'm from, so if I'm in a place where I speak English all the time, I won't be stuttering. Or I'll be of course be natural and not pause every time. Sometimes I run out of English words to say, and so just be aware of that. Okay. So for example, I have a fixed design, okay, like this, and auto mirror X, Y, and Z. Okay, so for example, I have this. See, and I want to play around with the topology because, of course, the operators are dependent on the result of the result of the operators are dependent on the underlying or your face selection or the topology of the face selection. So we can do this. We can create new wireframes using this and this to create interest in the result. But you don't want to really touch the um, topology of your object, so you can use the mesh data to save a copy of your mesh. Save. You can do this in object or edit mode. Then we can play around with the topology. Example, triangulate this or something like that. And then use the random operators. There we go. And if you've done with that, whoops, just load up the, if you want to bring back the old one, just bring it back using found two matching geometry. I think this is it. There we go. It's going to show you the matching geometry. So the first one, let's use this. It says found two matching geometry. So the first one will be the closest. The second one will be estimation percentage. So this is probably 100% and this is 50%. So the top one in the list will be the closest one with the matching geometry. Okay. And goes lower, lower, lower. So we now have our old topology back. You can clear the saved data using clear saved. I think it's two because I used the command earlier in object and edit mode. So for example, if I use save it first, if I use grid project here, increase the size. What the? And loop extrude. Nice. Okay, I got that. But then, oh no, I have to clean this up. You don't have to. You just have to use the data. Okay. Now you can play around with the topology of your source object and, of course, um, always bring it back to the original topology or resolution. And the saved data gets, if you save Blender, the saved data also gets saved. Okay, so don't worry about it. The only thing that will remove it is this one here, or if you manually remove it in the system. Okay, so that is it. And after this, we're off to version 1.6.0, where there's going to be a lot more improvements, especially with screws and also um, new functionalities maybe for the random cables. Okay, so that's it. I think this video is already too long because I have made this version I've extended this version for far too long, version update for far too long, so I'm going to pass it, then write the documentation afterwards after this video. So thank you for watching, and I hope you learned something from this video. If you have any questions, contact me through the uh, email in the store, the comment section, or probably best the email at the store or the Discord link in the description of the in the end of the documentation. Okay, that's it. Thank you for watching and have a nice day.